Hello everyone. This was an example that I've seen some people having difficulty with on IXL, so I wanted to make sure that I go over the ideas of this limit for you. So the first thing that you'll always want to try on a limit, of course, is to just put the number in where the x value is. So in this one, the problem is if you do that, you'll end up with 0 over 0 as your answer. And of course, that's undefined, so you don't want to just write undefined as your answer or feel like there is no answer for the limit, like a limit does not exist situation. That's not going to be the correct answer on this one. So one option would be to go onto a site like Desmos and graph this and kind of get a feel for what the limit might be at that spot. But another option is algebraically we can deal with this. Whenever we see a situation that is kind of an irrational expression like we have on the top there, a good idea is to multiply by the conjugate to see what happens. So when we multiply by the conjugate, square root of x plus 3, notice that that has a plus in it instead of a minus because the conjugate will have the opposite sign in the middle there, the opposite operation. So notice that the idea now is when I multiply the top parentheses together, I'm just going to get x for the first term times the other first term. And then the outside term would be 3 root x. The inside would be minus 3 root x, but those cancel. And then I have negative 3 times 3, which is minus 9. So the top becomes much simpler. And I'm actually not going to multiply together the bottoms. I mean, I'm going to multiply them, but I'm not going to FOIL or figure out what that expression is worth right away. I want to notice that I have an x minus 9 on the top, and I also have an x minus 9 on the bottom. So I can cancel those out, and you want to remind yourself what's left up on the top of this fraction. If I cancel things out like that, of course it's going to be a 1. The invisible 1 will show up now, and I have an expression of 1 over the square root of x plus 3. So once you've done this operation and you've canceled out x minus 9 on top and x minus 9 on the bottom, a really neat thing happens where this limit works out very nicely. I can now just put 9 in where the x is, and I'll get 1 over the square root of 9 plus 3. Well, that's 1 over 6. Now, it's a very interesting answer, 1 over 6, to this, because back at the beginning, this limit really seemed almost impossible at first when we got 0 over 0. So a good thing to do at this point would now be to go to Desmos and look at the graph of what's happening. If I draw just a quick little graph here, when you see Desmos graph looks sort of like this, and right here, maybe right about here, is where we have this value of x equals 9. But you want to notice it's actually undefined. Yeah, undefined at that spot. But as I come in from the left and I come in from the right, notice that the heights, the values of the functions, the function on both sides, is clearly approaching that same undefined value. And this is what we called a removable discontinuity when this happens. And back here in our algebra, when we canceled x minus 9 and x minus 9, that was the moment where we removed that discontinuity so that we could find the spot where those two sides are approaching the height of 1/6. So hopefully that makes sense to you. Let me know if you need any further explanation on this idea. But I recommend that you go back and try the group of questions on this content, rational functions and using conjugates.